In this video series, we're going to be looking at the SolarEdge for home backup wiring. We're going to be looking at the power optimizers, the home battery, energy hub inverter, backup interface, and the optional DC combiner. This video is looking at installation and wiring of the power optimizers. SolarEdge offer a range of power optimizers to suit different module types and power classes. So to start with, once the rail has been installed and you've set out the position of the panels, simply fix the optimizers to the rail using M6 or M8 stainless steel nuts, bolts and washers. Ensure that you leave 10 mm between the optimizer body and the rail to allow for adequate ventilation. Ensure that fixing the optimizer to the rail is with a torque of 9 to 10 Nm. Never use a rattle gun or an impact driver to fix the optimizers to the rail, because this may damage the optimizer. Once all of the optimizers are in position, complete the rest of the associated wiring and then connect each of the optimizer to its associated PV module. In this video, we're going to be looking at the wiring of the SolarEdge home battery. Simply wire the earth to the earth terminal bar using either 6 to 10 mm CSA cable. You'll notice that the earth terminal has two fixings. That's for if two batteries are being parallel together. Once the earth is in, we can then fix the DC. With the battery comes supplied two MC4 connections, so simply connect those to suitable PV DC 600 volt rated cable and connect them into the positive and negative associated terminals. The SolarEdge home battery comes with a couple of positions to fit cable ties. Use these to secure the cables in place. If two SolarEdge home batteries are going to be connected in parallel, you'll need to use the SolarEdge Y branch connector. So simply plug those in, and each of the associated DC connections, one from the additional battery and the second going back to the inverter. If only two SolarEdge batteries have been connected, these can be wired directly to the inverter. If however 3 SolarEdge home batteries are being used, you'll need to use the DC combiner. So for that, 2 batteries need to be connected together using the Y branch connector, and the third battery directly into the DC combiner. So for communications, the SolarEdge home battery comes with pre-installed the SolarEdge home network antenna and internal comms. If however this is not going to be used, you can also use RS485. For that, simply connect the RS485 cable through the supplied gland and wire it into the terminal blocks. For this process, firstly you need to undo the terminal block and remove it, and then simply wire in the ground and the two A and B terminals as shown here. And replace the terminal block. If two SolarEdge batteries are being parallel together, or 3, the RS485 connection can be daisy chained between each. As you'll see on the terminal block, there is an in and out connection for the RS485, so simply wire the adjacent SolarEdge home battery to the spare port on the terminal block. And that completes the wiring for the SolarEdge home battery. In this video, we're going to be looking at installation and wiring of the DC combiner box. The DC combiner box is an optional accessory which is only required if wiring LG Prime batteries or 3 of the SolarEdge home batteries. So to start with, mount the bracket, fix it to the wall with appropriate fixings to support the weight of the combiner. Fix the combiner to the bracket using the provided screws. Then you need to remove the cover and remove the glands to be able to bring the DC conduit and cables in. As you'll see, the combiner has 2 battery terminals, 2 input terminals for the PV-DC and 1 output going back to the inverter. The inputs allow provision for either a 25mm or 32mm conduit entry. So simply fix in place the associated conduit. You'll see inside the DC combiner that there are 2 earth terminal bars. These have been joined together. So you can use the earth supplied from the battery, as well as the earth coming from the PV, and then out from that back to the inverter. Ensure that all DC connections, whether battery or PV, use bootlace ferrules. This will ensure good continuity of connection . So to start with, we're now going to bring the battery DC into the first terminal block. This could either be for 1 or 2 SolarEdge home batteries. If the third SolarEdge home battery is to be used, we'd use that second terminal block. The DC combiner has the provision to take inputs from 3 SolarEdge home batteries. 2 of them need to connect together via the Y branch connector and the second directly into the combiner. The combiner is also used for LG Prime batteries. Once the battery connections have been made, it's now time to bring the PV DC in. So just as we did with the batteries, connect the earth and then connect either 1 or 2 array cables. Once these have been installed, we can then connect the earth and the positive and negative DC connections running back to the inverter. As the batteries will have a communications cable, that's whether it's the LG Prime or the SolarEdge home batteries, this can be provided through the same DC conduit as the DC, which can then just loop straight through the DC combiner, back out through the connection running to the inverter. Then replace the cover, and that completes the wiring of the DC combiner. In this video, we're going to be looking at the installation and wiring of the Energy Hub inverter. So to start with, mount the bracket on the wall and fix it with appropriate fixings to support the weight of the inverter depending on the wall material. The Energy Hub inverter comes with a pre-wired and connected antenna for Wi-Fi, so simply click that in position. So to remove the cover from the DCD to be able to access the AC and DC connections. The Energy Hub inverter comes with the provision for the inverter to be able to take conduit entries from 25 to 32 mil. So to start with, we're going to be bringing in the DC connections. This could either be from the DC combiner or direct from the associated PV and batteries directly. So simply plug in the DC, plus and negative terminals. For the DC, ensure that bootlace ferrules are always used to ensure good quality connection. If 2-to-1 connections are being used, so that could be from the battery and PV together, use a 2-to-1 bootlace ferrule. So the Energy Hub DCD has the provision to take all the various different earth connections. So from the battery, simply wire the earth. The Energy Hub also has the inbuilt Modbus meter. All that is required is for the CT connection to be wired. And then simply fit the CT onto the incoming connection from the grid with the arrow pointing towards the grid. And simply wire the AC connections to the gland with the markings provided: live, neutral and ground. Then in the switchboard, also simply wiring the neutral, earth and the live to an appropriately sized MCB. If wiring onto three-phase property and you require the three-phase voltage reference, simply remove the cover over the voltage connections of the meter. Pull out the AC connector and simply add the L2 and L3 references. Replace the connector and replace the cover. And you'd also then need to add the L2 and L3 CTs. For all the communications and other accessory connections, you need to then access the communications board. So remove the top cover of the inverter. As you can see, the inverter comes with a pre-wired Wi-Fi. However, if the Wi-Fi is not going to be used, remove the antenna. SolarEdge offer the Telstra SIM card accessory. So if this is going to be used as an alternative for the communications, simply add the comms board to the top of the communications panel and wire and connect the antenna. In addition, for communication with SolarEdge smart home devices, the SolarEdge home battery or the inline meter, you can connect the additional card for the SolarEdge home network. This will also require an additional antenna, which you can connect to the other side of the inverter and plug the card in. Alternatively, for communications, you can connect in RS485 Ethernet. If the SolarEdge home battery is being connected via RS485, you can also need to wire the battery to the battery terminal on the communications terminal connections on the left-hand side of the DCD. This port is also used for LG Prime battery connections. And then simply replace the covers. And that concludes the wiring for the SolarEdge Energy Hub inverter. In this video, we'll be looking at the wiring and installation of the backup interface. The backup interface allows for full or partial home backup. So to start with, mount the bracket onto the wall using fixings appropriate to the wall material to be able to support the weight of the backup interface. To access all the connections, you need to remove the cover. The backup interface has provision to take conduit entries from 32 to 40 mm. So for the AC connections from the grid, you can use between 6 to 16 mm CSA cable, to the loads between 4 to 10, or if a generator is being connected, between 4 mm and 16 mm. So the backup interface, if wired for whole home backup, as we are showing here, is wired between the grid supply and all of the loads. So what we're doing here is we're taking the incoming supply from the grid, then from that we're then taking it to an MCB, to the backup interface, from the backup interface back to this board to its own dedicated MCB, which then supplies all of the home load circuits. So the backup interface requires a comms connection between itself and the Energy Hub inverter. So you need to wire the ground A and B connections, as well as a 12 volt power supply. The backup interface also has inside it a CT, so the CT connection can also be connected back to the Energy Hub inbuilt Modbus meter. Once all the connections are made, simply replace the cover. Tightening all the screws to 3 Newton meters. Then inside the Energy Hub DCD, you need to wire the communications cable to the backup interface terminals, ground A and B, as well as the 12 volt power supply. And the CT connection can be connected into the CT L1 terminal. And finally fit the small 9 volt battery into the supply terminal in the DCD. And that concludes the wiring of the backup interface to the SolarEdge Energy Hub inverter. Replace the cover of the DCD, and that concludes the installation.